All right, so now we're going to practice solving equations with imaginary solutions, and our goal in these problems is going to be getting x by itself. And so our strategy is going to be using the opposite of order of operations since there's only an x. So order of operations is parentheses, exponents, multiplication, division, addition, subtraction. And so going in reverse order, we're going to look for addition, subtraction we can get rid of. And since I see a plus 6, we're going to use a minus 6 on both sides, giving us x plus 2 squared equals negative 6. Our next step will be to take the square root of both sides, getting rid of the squared, which leaves us with x plus 2 equals plus or minus the square root of negative 6. Typically at this point you would say no solution because we can't take the square root of a negative. But due to the fact that we're having imaginary solutions, this is going to be simplified to plus or minus I radical 6. So when you pull I to the outside, it gets rid of the negative under the radical. The square root of negative 1 equals I. And so that is where we get the I in front of the radical 6. Our next step will be to subtract 2 from both sides, and that gives us a final solution of negative 2 plus or minus I radical 6. All right, our next problem again, we just see an x, so our goal is going to be to get it by itself. And again, the same strategy using opposite of order of operations. So we're looking for addition, subtraction to get rid of. And I see this minus 16, so we add 16 to both sides. This gives us negative 2 times x minus 4 squared equals 36. Our next step will be to get rid of the multiplication by negative 2 with division by negative 2. And this gives us x minus 4 squared equals negative 18. Get rid of the squared with the square root. And again, we're square rooting a negative, which typically gives us a no solution. But because of imaginary numbers, we can write this as plus or minus I radical 18, which we will simplify again here in a minute. And so our next step is to add 4 to both sides. And so giving us a solution of x equals 4 plus or minus I radical 18. Now technically that is correct, but we do want our answer to always be in lowest terms. So if we just focus on the radical 18, we want to see if we can simplify this radical. So we want to think of any multiple of 9 that is a perfect square. Perfect squares being numbers we can take the square root of and get a whole number as a result. And so 18 can be written as 9 times 2. And the square root of 9, so that can be written as the square root of 9 times the square root of 2. The square root of 9 is 3. The 2 can't come out of the radical. And so our final solution for this is x equals 4 plus or minus 3I radical 2. All right. In our next example, we see there is x and an x squared. Due to that fact, I know that we're probably going to have to factor. So we try factoring, and I think we can quickly realize that there are no multiples of 16 because they are 1 times 16, 2 times 8, and 4 times 4. There are none of these multiples that can give us a negative 4 with their sums. So that takes us to the quadratic formula, which is negative b plus or minus the square root of b squared minus 4ac all over 2a. And so to identify our a, b, and c, we look at the coefficients in front of our terms. And so the standard form equation for a quadratic is ax squared plus bx plus c. So the a will be located in front of the x squared, and so our a equals 1, our b equals negative 4, and our c equals 16. And so when we substitute this into our quadratic formula, we get negative times negative 4 plus or minus the square root of negative 4 squared minus 4 times a, which is 1, times c, which is 16, all over 2 times 1. And so the negative 4 makes a positive 4, plus or minus the square root of negative 4 squared is 16, minus 4 times 1 times 16, so 64, all over 2, which simplifies to 4 plus or minus the square root of negative 58 over 2. Now, the least you can do in simplifying a radical with a negative is moving an I to the outside. And so 4 plus or minus I radical 58 over 2. Now, whether or not the 58 can be reduced or simplified under the radical, we need to determine, are there any perfect squares that go into 58 a whole number of times? My suggestion is if you take 58 divided by 2, you get 29. 2 would be the least number of times a whole number could go into 58 a whole number of times besides once. So if we divide 58 by all the whole numbers that are less than 29, which would be 4, 9, 16, and 25, you'll notice that none of these numbers go into 58 a whole number of times, meaning 58 is not reducible. So our final answer is this in the radical form.